Okay, so today we're still working with solving inequalities, and we're going to be for a while here yet. But today what's different is, with this time when we look at our inequality, it's going to have variables on both sides. So that's why we practice solving an equation that has variables on both sides, just to remind ourselves we know how to do this. So when the variables on both sides, really our first move should be to get them collected onto one side or the other. It doesn't matter which side. So we want to collect them on one side or the other. So the first thing you want to move are the variables from one side or the other. So let's look at our first one here that we're going to practice. We have 5x plus 1 is, what's that symbol say? Is less than negative 2x minus 6. Who wants to make a suggestion for a good first move here? Trey?
What my teacher at my old school told me to do is when it's like this, multiply them, like add them when it's negative to the one that's positive.
Yeah, if you have a negative one and you have a positive one, typically a good thing to do is get the negative one off of that side. So before we do that, let's first write this as and add the opposite problem, okay? So we're going to have 5x plus 1 is less than negative 2x plus negative 6, because we keep making, some of us keep making that same mistake thinking you can read subtraction backwards. Well, now that we've got it as addition, now we can read it backwards and say, if we're going to move the negative 2x, it's being added. So what do we add when a negative is being added? What do we do to undo that?
Add its opposite.
Add its opposite. So we're going to add 2x to both sides. So now we have 7x plus 1 is less than negative 6. And another good reason for making sure we do that changing subtraction to add the opposite is so that we treat that 6 properly. Sometimes we like to think, okay, it's just a positive 6, but we can see it's really a negative 6. Okay, now, we don't have any fraction involved in this at all. We don't have any parentheses. So what did we say we're going to undo first when we don't have that situation? Yeah, we undo the adding or subtracting next. So what's going to be our move here?
Minus 1.
Yeah, we look on the side where the x's are now, and what do we need to get rid of? We need to get rid of that 1. So we'll subtract it. And now we're going to have 7x by itself. That was what we were trying to do. Negative 6 take away 1.
Negative 7.
Negative 7. It's 6 below 0. The temperature drops another degree. Now it's 7 below. And our final move here in solving is?
Divide.
Divide by what?
7.
Positive 7, because x is being multiplied by positive 7. You always divide by what it's being multiplied by. So we get x alone. Did we divide by a negative? No. No, so we don't need to switch the symbol. Negative 7 divided by positive 7. Negative 1. Okay, so there's our solution. And the question was asked earlier, are we going to have to graph again? Whenever we solve linear inequalities, we're going to graph them. So at negative 1, what kind of a circle do we want?
Open.
Just an open one, yeah. And the integer neighbor to the right and the left get identified. What's the integer neighbor to the left? It's negative 2. And 0 is the one on the right. Which numbers are less than negative 1?
Negative 2.
Negative 2, those guys on that side, so we're going to shade to the left of negative 1. And again, remember, when the variable's on the left side of the inequality, whatever way the arrow's pointing, that's the side we actually should end up shading, don't we? Okay, so any questions about that one? Okay, look at this next one. What's different about this one that we didn't have in the last one?
There are no negatives.
No, yeah, there's no negatives. That's good news. We kind of like that. No negatives or subtractions. Cameron?
There's not a second number on the left side.
Yeah, we don't have a number being added or subtracted from the a's on the left side. So let me remind you how we deal with it when we have variables on both sides, but they don't both have a number being added or subtracted with them. Typically what we want to do is we want to get those A's that are already by themselves, we want the other ones to come over and join them, because they're already by themselves. So let's just bring some more A's over with them, and then we'll have them alone, and we'll be able, in other words, I'm trying to help you be able to create less steps of work. So because that 4A is already by itself, we are going to get the 7A moved, and what do we have to do? Subtract it, yeah. Not saying you absolutely have to do it this way, but I'm trying to help you create fewer steps of work. And some of you don't know what to do if you would have started by subtracting 4A, you kind of lose track of what should happen because you take 4A away from 4A and you forget to put a 0 there. So what is 4A take away 7A? Negative 3A. And we have 6 left on the other side. Okay, what would be our next move? Divide by negative 3. So negative 3A gets divided by negative 3, and 6 gets divided by negative 3.
And if you divide or multiply by a negative, you have to put the thing.
Yeah, so we divided by a negative, so A is by itself. We divided by a negative, so we have to reverse the symbol, and it's negative 2.
How?
And the other really nice thing about this one is that it also turned out that our variable was on the left side. So that's a cool thing too. We don't have to rename it. And now we will graph it. What kind of circle are we going to put at negative 2?
Shaded.
Shaded in one. Okay, integer neighbor to the left? Negative 3. Integer neighbor to the right? Negative 1. What numbers are greater than negative 2? Negative 1 and all those guys on that side. Okay. Any of you that like to work ahead, not do the same steps we did?
I tried to work ahead, but then I got confused. I was like, never mind.
You said to stick with us. In other words, if we don't all do this in the same order, that doesn't mean we can get a different solution. We can do different steps. We can create more work for ourselves than we have to, than we need to, but we still in the end should get the same solution. There's only one inequality solution to this one. Okay, I think we have a word problem here to do. Okay, create an inequality to solve the following problem. Why don't you read that little, I guess it's all one sentence there, to yourself. Okay, so it looks like you're going to purchase a ski ticket. And you want to know which plan would cost less than the other, according to how many days you ride to ski. So they're going to give us this information. They're going to say Plan A costs $45 a day and includes the lift ticket and equipment. So you just have to pay $45 a day and everything else is included, right? Plan B costs $350 for the season. So in other words, no matter how many days you're going to go skiing, they're going to charge you $350 to join, and includes the equipment, but not the $20 lift ticket each day. So you get to go, when they charge you that $350, you get to go and ski as many days as you want or as few days as you want. They don't charge you anything for showing up because they've already charged you $350, but they're going to charge you, and they're not going to charge you for equipment. You need to use their equipment, but they are going to charge you $20 lift ticket each day. So we want to know when one's going to be cheaper than the other and what number of days that would be. So what do you think X is going to represent in this situation? What's the
Number of days.
Number of days. It's the thing that we get to decide how many days we're going to do it. So let X represent number of days. Well, according to, with X being the number of days, what would you have to do for Plan A? Just what expression? Don't even need to write a whole inequality here right now. I just want you to give me an expression, an algebraic expression for Plan A.
45x.
45x. It's $45 per day. Is there any other charge?
No.
No. Okay, how about Plan B?
350 plus
350 plus just 20?
20x.
Don't you have to buy a lift ticket every day? 20x? Yeah. You pay $350 one time. Every day you go skiing, you have to buy that lift ticket. Okay, now we'll go back to the question that was asked, where it said, for which number, we're going to solve for the number of days for which Plan A costs less than Plan B. Plan A is less than Plan B. So let's write that down here. Plan A is less than Plan B. So what could we replace Plan A with in that?
45x.
45x. What could we replace Plan B with?
350 plus 20x.
350 plus 20x. And look at what we have. An inequality to solve with variables on both sides. Anybody want to make a suggestion what they think we should do to start solving this? Jade or JC?
Subtract 20x.
Subtract 20x. These 45x's are hanging out alone over here already. Leave them alone. Bring the other x's over to them. So now what does our inequality read?
25x is less than 350.
Okay, 25x is less than 350.
And divide by 25.
And our next move would be to divide both sides by 25. Okay. So x is now by itself. Did we divide by a negative? No, so we don't need to switch the symbol. And how many 25s are there in 350? 14. And remember, x is what again?
Days.
Days. So we're saying x needs to be less than 14 days.
Do you want us to do this in a sentence?
Oh yeah, that's exactly what's coming next. We're going to write a sentence answer now. We're going to go back up and answer the question that they gave to us to begin with, and we're going to state it in sentence form. So it says, for how many days would Plan A cost less than Plan B? If you ski, this says, if you ski
Less than.
less than 14 days, okay?
Should we say less than 2 weeks so that way it's...
Well, we kind of were talking about it in days, so it's probably just might as well leave it in days. If you ski less than 14 days, how should we finish it?
Punctuation.
Well, we're not quite done though with our sentence. We are going to punctuate it though, you're right, when we're done.
If it's less than 14 days, comment, Plan A would be less than Plan B.
Okay, Plan A costs less than Plan B. What kind of punctuation should we use?
Oh,
A period now. Okay, if you ski less than 14 days, Plan A costs less than Plan B. Anybody think they know how many days it would be they'd be the same?
Like 5.
in 5 days.
No.
I don't think it's correct.
We should figure it out.
No, it shouldn't.
I bet it's 14 days. What do you think? I bet it's 14 days. What if we put an equal sign there? Hey, you guys, remember, I'm asking you, when would it be the same? What if, instead of having an inequality statement here, we would have said, okay, I want to know when Plan A is equal to Plan B. So then we would have put an equal sign here instead, and then we would have solved it, and we would have gotten x equals 14.
14 is
I bet it would have been the 14 days. They would have been the same, right?
No.
No, you're not convinced.
No, I just multiplied 45 by 14.
And what'd you get?
630.
Okay, 45 times 14 is 630. Okay. Plan B. What do we have to do for Plan B then?
Start 350 times 14.
350 plus,
Do we write this down?
no, you don't have to. 20 times 14. What's 20 times 14? 20 times 14?
Oh, 20.
34.
20 times 14. 2 times 14 is 28, and put a 0 behind it. Oh, goodness. 350 plus 280? 630.
Oh, dang.
Huh. Isn't that something? Okay.
Look, I